Hello, everyone. Today we're going to start our unit on probability. So, probability is used to make predictions. It's used in the fields of math, of application math. Probably the most common field you know of it is gambling. There's probabilities with that. Probability originated, or the study of it really became popular in France. So a lot of French mathematicians are famous for their studies on probability. And today we're going to talk about the difference between experimental probability and theoretical probability, and really the overall definition of what is probability. So let's take two dice, two six-sided dice, and I roll them. Is that roll more likely to be even or odd? Make a prediction, write down what you're thinking, and we'll see if you're correct. Now, I've heard many justifications over the years of, well, if I look, the sums could be 2 through 12, 2, 3, 4, 5, 6, all the way up to 12, and there's more even sums. And then some people argue, well, 7 is the most popular number on a die, on two dice when I roll them. So since 7 is odd, the sum is more likely to be odd. Now, in reality, the sum is equally likely to be even or odd, because out of these 36 outcomes, I listed what we're going to learn as a sample space. There's 18 evens and there's 18 odds. So we'll call this a fair experiment. 50% evens, 50% odds. Now we're going to learn about experimental probability today, which means if I roll the dice 10 times, I might not get 5 evens and 5 odds, because experiments aren't always 50-50. So today we're going to talk about experimental probability, which is probability based on doing the experiment, versus theoretical probability. What should happen based on the odds in doing an experiment a million times or 100 million times? So we're going to start by exploring. Now I want you to roll two dice. I've come up with a randomizer online. You could search your random dice or random dice randomizer, or you can have two dice. I want you to roll two dice, find the sum, record it, and do it about 25 times and find the average. Okay, and record your average. And think about what would happen to the average if I did it 50 times or 100 times or 1,000 times, and we're going to discuss that. So pause the video, take a few minutes, roll two dice, record the sum over and over again. Okay, now when I did it, my average was 7.12. Okay, I rolled the dice 25 times, and all of the sums added up to 178. I divide that by the 25 times to get 7.12 an average per roll. Now, if I do more trials, the outliers, the rolls where I get two ones for a sum of 2 or two sixes for a sum of 12, are going to be less frequent than the rolls in the middle. So doing more trials brings the average closer to the expected value, or the theoretical probability. So experimental probability is what actually happens when running an experiment a finite number of times. Now, the more data I collect, the more likely my result's going to get to the theoretical probability, which is what ideally should happen. Okay, if I roll two dice a million times, the average is going to be really, really, really close to 7. 7 is the theoretical sum of rolling two dice. It's the most likely, it's right in the middle. So if I roll a fair die 60 times, I roll one die, So 1 through 6 are possibilities. The number shows up, 3 shows up 15 times. My experimental probability is 15 out of the 60, and I can simplify that fraction to 1 out of every 4 times. So I see a 3, 1 out of every 4 times. Now the theoretical probability, I know that. I should see a 3, 1 out of every 6 times, because 1/6 of the die, one side shows a 3. The theoretical probability will never change. The experimental probability might change. Maybe I do the experiment again, and I only get 7 3s. That's the difference between experimental and theoretical. So what's the theoretical probability that when you roll 2 dice, you have a sum of 5? Think of what outcomes could get you a 5. Then I want you to go look at your sums, your rolls, figure out how many 5s did you get out of 25. And then if you really want to, you could do about 200 rolls or 100 rolls, however many rolls you want, and determining what the experimental probability is with more trials. So pause the video, take time with this, look at the theoretical and the experimental probabilities. Okay, so my sample space for rolling a 5, which means the different outcomes that could get me a 5, I could roll a 1 4, a 2 3, 3 2, and a 4 1. So out of the 36 total rolls, 4 of them have a sum of 5. So 1 out of every 9 rolls, I should have a sum of 5. And I can make it as a fraction or a decimal. Now, depending on what your trials were, okay, when I did this for 25 trials, I only had 2 rolls that were a sum of 5. So my fraction, my experimental probability was 2 out of 25, or 0.08, which is less than the theoretical probability, and that can happen. Now, I also did this for 200 rolls. When I did 200 rolls, I got 23 rolls which had a sum of 5. And 23 of the 200 is 0.115, which is closer to the theoretical. And that's what we're going to see. The more rolls we do, it's called the law of large numbers. Okay, the bigger my experiment, the more trials I run, the closer the experimental probability gets to the theoretical. So the experimental probability is what actually happens when we run the experiment. The theoretical is what should happen when running an experiment an infinite amount of times. And as the amount of trials gets larger, the theoretical probability stays the same, and the experimental probability approaches that theoretical. So if I roll 2 dice 10,000 times, I'll probably see 1 out of every 9 rolls, or about 1 out of every 9 rolls, have a sum of 5. Because that's my theoretical probability. Now we're going to take throughout this chapter and look at theoretical probabilities of different events with cards and dice and coins, which have randomness to them. So we can't influence what's going to happen. We're just going to look at their probability.